Today we'll be talking about breaking the blood-brain barrier. Pointers from C to Python and back. For this presentation, I'll be using a problem from Rosetta Code. Rosetta Code is a repository of common programming problems and their solutions in different programming languages. The problem I've chosen is calling a function from a foreign language. This problem is not yet solved in Python. Consider the following C source code. Write an implementation of query in your language and make main calling it. The function query takes the buffer and places the string "here am I" into it. The buffer size in bytes is specified by the parameter length. When there is no room in the buffer, query shall return 0. Otherwise, it overwrites the beginning of buffer, sets the number of overwritten bytes into length, and returns 1. Here we go. We will be embedding Python in a small C program. For the sake of example, we will not use any third-party wrappers like Boost Python. For the sake of example, we will not return the modified buffer and length, but rather modify them directly from Python. For the sake of example, we will keep Python value error checking at a minimum. Here we go in C. We initialize the Python runtime, construct a Python string specifying the module we will load, and then we import it. We get the module dictionary from the imported module and look for the query function. Next, we allocate Python buffers, read-write buffers in this case, taking pointers from the variables we're supposed to interact with. Next, we call our query function and pass the appropriate buffers. Then we get the return value and process it. From this point on, you will notice that we use buffer and size without attempting to extract them from the Python buffers, since we have changed them in place. Next, we dereference the allocated Python objects in inverse order of allocation, and then we clean up the Python runtime. Here we go in Python. Our makeQuery Python module file defines the following function. This function, called query, takes two buffers and defines a payload and a payload length. Next, it creates two structs for unpacking data to and from buffer parameters. This is merely for convenience, so I do not have to deal with buffers on a byte per byte basis. Next, we unpack the length from the buffer, and we react accordingly. If the buffer length is less than the payload length, we return 0. Next, we pack our payload and our length into the appropriate buffers and return 1. And it works. Here's a brief rundown of what we did. We created read-write Python buffers. The buffer class will create read-only buffers when called from Python, but is much more flexible when used from the Python C API. We passed a pointer using buffers and struct. We use unpack from and pack into to read and write from a buffer pointing to an actual location in memory. We engage in manual garbage collection of Python objects. Python objects allocated by you are owned. Python objects not allocated by you but received as a result of a call are borrowed. You must remember to always deallocate owned objects. For some final thoughts, there are plenty of Python tasks pending implementation on Rosetta Code, and you can find the source code for my example at my Bitbucket. The link will be at the end of the presentation.